All right, I'm going to talk about the electrical panel now. And again, I just want to warn you, if you listen to me, you're getting bad advice. Right? Half of what I say is wrong. Please consult a licensed electrician. Or your kid or your husband or whatever. So here we go. This is a Cutler hammer panel. And I think they bought Eaton. So you're going to see some Eaton gear in here. Here's some more Eatons. Whatever. So you can tell pretty much when the house was built by the inspection sticker. 12/29/03. And generally, so the house was completed in 04. Usually where people aren't going to be pulling wires through, contractors aren't pulling wires through, the HVAC people aren't in, the plumbing isn't being run until the house is closed up. So, and that would be like your openings, doors and windows. That would be the walls, not the interior, not your finished siding product. Just what they use these days is probably OSB, oriented strand board, which is like this. It's just as long as to pretty much keep the elements out. And your roof, of course, the roof needs to be covered up, and it doesn't need to have the shingles on it, just covered up. So, so what people like contractors try to do is they try to time it so they're in the house by the fall or before it gets really cold. Right, so that's probably what happened here. Right, they got in the fall, they pulled some wires for a month or less, and they probably a couple of days, and they, so when you're working indoors and you're out of the elements, sort of, you can have kerosene heaters running to try to keep the place warm, and also when they're building too, you want to like pour your foundation and stuff when it's warmer. You don't want this stuff to freeze. Your concrete to freeze. Or your slab in the garage, which actually there might be an issue with mine, but and when contractors are ordering concrete and the forecast is for it to freeze, they'll order it with high early, and then the quarry adds this. It's an additive called high early, and it helps it cure and set during inclement weather, stuff like that. So anyway. So what we got here is a 200 amp service. That's pretty standard for our neighborhood. Not pretty, it probably is standard for our neighborhood. And this is a mechanical interlock, and this is what I call my poor person's backup generator solution. And the reason why I did that was because even though I'm an end unit and there's a lot of space outside, not a lot, but there's room outside, I could not find a location to place permanently place a backup generator that was far enough away from the openings. So you can't put one, you shouldn't put one within 5 feet of like a door or window or something. And some codes might call for 7.5 feet or 10 feet. I didn't even have 5 feet, so I couldn't do that. So I got a little larger portable generator, right, with wheels on it, and I could pull it in and out of the garage. And then I had this one I didn't put in myself. I had a licensed electrician do this. It's a 50 amp circuit. Now, the way this is, like, the permanent backup generators, within a minute or two, they sense the power's out and they'll switch over to backup power. And before, with the portable generators, what we would do is we would have like another panel here, a small, not a panel, like a box. It could have like 5 switches on this side, 5 on that. That's called a transfer switch. You would kill the power, and then you would flick these things on. Really, you didn't have to literally kill this one, but if I wanted this and this to be backed up on the backup generator, I just flick that and that off. You're safer. With the transfer switch, you're better off just flicking the whole thing. But where was I? So I had the electrician install this 50 amp circuit. Like my previous backup generator was 30 amp, and that could produce, like, say 8,300 watts. If I'm not mistaken, that will be peak watts, not constant. And by peak, I mean it's like when something kicks on, like the the compressor of your refrigerator, when that kicks on, it's drawing more power initially. Once it's running, it's not drawing as much power. So it's an 8300, a backup generator spec at like 8300 watts isn't going to be giving you 8300 watts continuously. It could go up to that. So this was a 50 amp, and this backup generator was it's actually dual fuel. So it was over 13,000 watts peak, and depending on the fuel. So it could run on either gasoline or propane. With gasoline, it's over 13,000. With the propane, it was like 12,400 or something like that. So the propane wasn't able to drive the engine generate as much power. And the reason why I went with propane, what I did was I got a propane tank that sits up about, I don't know, maybe 5 feet high. And they have hand trucks that you could put that are designed for those round tanks. So I got a hand truck, I put the tank on it, and you could strap it in so it wouldn't fall out. So I could wheel out the backup generator, wheel out the propane tank, make a connection and fire it up, come down here. And the way this worked is I couldn't turn this on. I couldn't feed the house unless I shut the main off, right? Because I don't want to back feed, because this will just, it would get black, right? It would just arc, or worse. So once this is shut off, then that's why it's called a mechanical interlock. That space would allow this thing to slide up. See, I can't go up, and that would allow this to be able to be turned on. So now my previous home, I had a shed, so I could put my gasoline in the shed. Here, there's no way I had 3 5-gallon containers. There's no way I'm putting 3 5-gallon containers in my garage that's connected to this house and other houses, right? So I went with the propane. And what I did before, like when I did have a place to store the gasoline, I would put stabilizer in the gas so it wouldn't skunk, right? Because it loses octane and it would gum up, it wouldn't start, it would mess up your carburetor. So with the stabilizer, the fuel stabilizer, the gasoline can sit. But I didn't let it sit for more than 3 months anyway. I still use the stabilizer, but at the beginning of each season, right, spring, summer, winter, fall, I would take those containers, 5-gallon containers, put the gas in my car, and go and fill them back up again, and put some stabilizer in it, and store them in the shed. So I just didn't want to do that here. We definitely didn't feel comfortable doing that here. So where are we at? Okay, so we got that 50 amp circuit. We have another 50 amp circuit. This is for the range. Now this range, actually, it's the oven that's electric. So when I actually pulled out the oven to get the hardwood floors for him to finish underneath it, there was a gas line connected to it too. So the stovetop is gas and the oven is electric. So 50 amps seems like a lot, but I don't know. The air conditioning is 30 amp. These are called double pole breakers, right? This is 30 amps distributed over in those 2-slot double pole. They're connected together. That allows you to come in with 2 wires, which means instead of like a regular 1 wire, where are we at? There we are. 120 volts. The double poles give you 240 volts, right? So for your meatier stuff, you need that. And then I ran this to the garage for a table saw. So I just leave that off. And then the house was initially wired for a dryer. And it looks like they added a gas line after they moved in to the laundry room. So I have a gas dryer, and that's why this is off. But that's also 30 amp. So you know when you're seeing a plug like that, it's a 30 amp. And then I added these to my electrician said use AFCIs, arc fault circuit interrupter. He said anything you change, if you touch the circuit, replace it with an AFCI. And an arc is when like 2 bare wires touch and you see the spark or the arc. and that's becoming more of an industry standard. It would happen more in older homes, but if you have a wire behind a wall, like running up to the second floor, and it arcs, that could start a fire, right? So you want to kill the power as quick as possible to that circuit. And does it happen to these new wires? It could, if there's a rodent in that gap and it's munching on that stuff. It's, in theory, it could happen. So that's what the AFCIs are for, and these will trip in, like, I don't know, 20 to 30 milliseconds. They're very sensitive. And then where a regular breaker is not. It's still sensitive, right? But it won't trip that quick. As a matter of fact, it could take 15 to 20 minutes for it to trip. And I can tell you how I did that once. So in my previous home, I had my... Oh, see, I just shut that off. I don't know what I shut off, but since it's not labeled. Yeah, so I had my table saw, and I'm ripping down like 2x8s. Wait a second, I just got a message from my alarm that my power just got shut off. So now I know what I just shut off. Okay. I'm ripping, I got pressure treated 2x8s, right? And they're laying them flat, and I'm ripping them down on my table saw with a friend of mine, cutting them in half. And then I'm getting the one piece, the half piece, flipping it up on edge, ripping that down in half. And the pressure treated wood 40 years ago, it was wet, it was more toxic, and it was just adding a lot more stress onto the motor of the table saw. And after like 15, 20 minutes, it stopped working. And I was like, wow, I think I just overheated the motor of the saw, and it was a safety, and it shut off. Actually, no, it wasn't. The breaker shut off. So this could like warm up. It could take, it's just not instant all the time. Could be a couple of minutes, and if it's being strained for too long, for a couple minutes or whatever, it'll pop. So we talked about the AFCIs, and so that's for like my technology and stuff too. And you can tell actually the AFCI breakers, because they have a little coil on the inside, like a wire that's coiled up when you're plugging it, when you're grounding it and stuff. So those are running over there. 2 20 amp circuits to the technology. I just wanted that on independent circuits.